Okay, so we are going to look at the sum and difference identities, and the top of the notes, I'm a victim of my fraction bars disappearing again. So I'm going to put that in there, and that in there on the tangent ones. Okay, so obviously they're on the top of your notes, but if you look at your identity charts, they are right here before the split. So make sure you know where to find them on here as well. And we're going to start by just condensing them. So if you look at, you've got sine of a plus b, cosine of a plus b, tangent of a plus b, then all the minuses over here. For the sine ones, you have sine times cosine. For the cosine, you have cosine times cosine and sine times sine, so that's one way to kind of easily recognize them. And then tangent is the big old fraction, so it's kind of hard to miss. So if I look at number 1, my goal is to condense it into a single logarithmic expression, then find the exact value. So this definitely looks like a tangent one. I just have to decide if it actually is 100% like that and something isn't off with the a's and the b's. And would it be tangent of a plus b or tangent of a minus b? Minus b, okay? It pretty much looks like this one, right? So this whole fraction, this whole thing is just equal to the tangent of 5 pi over 18 minus the, minus pi over 36. All right, so, and we're doing this because I don't know what the tangent of 5 pi over 18 is, and I don't expect you to either. So then here I need to combine these two fractions. When I subtract, what's my common denominator going to be? 36. So with a common denominator of 36, that first fraction has to get multiplied by 2 over 2. So this is 10 pi minus pi. So this gives me the tangent of 9 pi over 36. Can I reduce that? Yes, that becomes tangent of what? Okay, 3 pi over 12, which will reduce to pi over 4. And then what's tangent of pi fourths? What is it? 1. That's your answer. Okay. What questions you got? We good? All right. Okay. So then when I look at number 2, I've got sine of a times cosine of b, and the one that mixes sine and cosine is the sine. And since this is minus, it's sine of a minus b, because sine of a plus b is plus, sine of a minus b is minus. So this is just going to give me the sine of 13 pi over 10 minus 2 pi over 15. What is my common denominator going to be here? 30. So it's going to be the sine of something over 30. So that means this has to get multiplied by 3 over 3. That'll give me 39 pi minus 4 pi. So that is the sine of 35 pi over 30. What is that? What does that reduce to? 7 pi over 6. All right. So the sine of 7 pi over 6, is that going to be positive or negative? Negative, and it's a negative what? 1/2. What questions you got? I'm sorry, you have to say a little louder. How did I get what? How did I get this right here? Yeah, straight from this right here. Does that make sense? That's okay. Okay, because I'm not actually doing this. This is this right here, and since it matches, I'm just jumping to this. Does that make sense? We're kind of going backwards. All right, does that help? Yes? You good, Estella? Brianna, you good? Okay, awesome. Everybody else, we good? All right, sweet. Okay, number 3. All right, so number 3. This matches this whole thing, right? This is my A, this is my B. So tangent of A, this whole thing. So I'm not messing with this hot mess of this fraction right here. Since this equals tangent of A plus B, that's literally what it's going to turn into, okay? So this is going to become tangent of A, which is 4 pi over 15, plus 17 pi over 30. You finished that up. Wow me with your 4th grade math skills. So that's what I got in the end. Anybody have any questions? All good? So let's look at number 4. It's cosine times cosine minus sine times sine. So is this going to be a cosine or a sine by looking up at the top? Cosine. Is it A plus B or A minus B? A plus B. Even though there's a minus here, it's A plus B if you look at your identity. So this is the cosine of 5 pi thirds plus pi 12ths. You finish that one up. All right, what questions we got? Anything? Square root of 2 over 2? All right, so that's when we can actually have angle measures and evaluate in the end. But now we're going to simplify like we've been simplifying some of the others, which means we won't necessarily, I mean, we might get a number in the end, but that's not really our goal necessarily. All right, so we have got, on number 5, we have cosine times cosine and sine times sine. So is this going to be a cosine or a sine? Cosine, is it cosine of A plus B or A minus B? Minus. So this is going to give me cosine of 2x minus 4x. So this gives me the cosine of negative 2x, but I don't leave it like that. That 2x represents an angle, right? So that's the same thing as like negative theta. So look on your identity chart, and there are cofunction and even and odd identities that we looked at the other day, but we really didn't use. So look at your even odd identities and tell me what is the cosine of negative theta equal to? Cosine theta, right? So cosine of negative 2x is the same thing as cosine of 2x, and that's my answer. Okay. Is that going to work out the exact same way for every trig function? No, and that's why it's on here, because it was the same for all of them. We won't have to worry about it. So you got to look at that. You have to actually look at this chart if that's something you need. Okay. All right, so let's look at number 6. This looks like it should match a tangent one. Would this be tangent of a plus b or tangent of a minus b? Plus b. So this will give me tangent of 4 theta plus theta, and that gives me tangent of 5 theta, and there's really nothing else we can do to it. That's as simplified as it gets. Okay? Easy enough? All right, so let's look at number 7. Sine times cosine, cosine times sine. So is this a sine or a cosine? Sine, is it a plus b or a minus b? Minus. So this is going to be the sine of pi halves minus alpha. Okay, can't just leave it like that. Look at your cofunction identities on that chart, kind of the middle of the top. And what is the sine of pi halves minus alpha? Cosine of alpha. Yeah, it's cosine theta on there, and then cosine alpha here, and that's it. Okay, just get it straight from the identity chart. It's not anything magical happening there. All right, so number 8 looks like a tangent one. It matches. Is it a plus b or a minus b? Minus b. So this is the tangent of y minus pi halves. Okay, so does that match the cofunction identities? No. Close, but no cigar, right? Okay, so for the cofunction identities, it would have to be pi halves minus y, right? So I can switch them around, but when I switch them around, the signs have to stay with the values, so this becomes the tangent of negative pi halves plus y, right? Is there something I could legally, algebraically do just to the inside of this so that I could actually get pi halves minus y? I could factor out a negative. So this is going to be tangent of, I'm going to factor out a negative, so it leaves me with pi halves minus y right there, like that. Okay? Everybody okay with that? Does that make sense? You're just factoring out that negative. Okay, so this right here is just some angle measure, right? Whatever it is, it's some angle measure. So this is the same thing right here as tangent of negative theta. Right? That's basically what that is, tangent of negative theta. So look at your chart. What is the tangent of negative theta? Negative tangent theta. So since this is tangent of negative theta, I can bring the negative out front. It's just negative tangent of pi halves minus y. This negative, I factored out in here. That's just literally GCF factoring like we've done before. To get from here to here, I did not factor out the negative because you can't do that. I used the reference chart. Okay, it's an identity. So now that I have negative tangent of pi halves minus y, I can look back on here. I do have something that would match tangent of pi halves minus y. What's that? Cotangent. So I saw this negative out front. It's negative cotangent y. What questions do you have? We all good? Awesome. So your assignment again is in formative and on a worksheet. So I'll give that to you in just a second.